Hi all, let's take a look at, this is number 21 in the section 4.6 homework assignment. It's an excellent question someone asked here. So this one is giving me, it says a logistical growth model for the world population. That world population is going to be defined to be f of x, and that population is measured in billions, x years after 1959. Now it says f of x is equal to 12.7 divided by 1 plus 4.11 e to the negative 0.026x power. This is a logistical growth model. According to this model, when will the world population be 10 billion? So just it says, according to the model, the world population will be 10 billion in, and it's just wanting the whole number year, I believe there. So here's what I did in order to think about that. I took their equation. 10 is equal to 12.57 divided by 1 plus 4.11 e to the negative 0.026x. So I just wrote the problem down, and I knew that the y value I was looking for was when the world population would get to 10 billion. And remember, y is measured in billions, so you can just put the 10 there. You don't have to physically write out 10 billion. Now, I knew I couldn't solve for a variable as long as that variable's in the denominator. So the first thing I did is I multiplied both sides by the denominator on the right, which means now my right-hand side is just 12.57. At that point, I said, well, I have 10 times this group. Let's go ahead and distribute 10 times both terms. They gave me 10 plus 41.1 times that exponential function is equal to 12.57. Now I got the exponential function by itself by first getting rid of the 10. You subtract 10 on each side to get 2.57 on the right. Then you can say you can get rid of the 41.1. It's multiplying e by dividing 41.1 on each side. So now when I got that exponential function by, and it's extremely important that you understand the necessity, I had to get that exponential function by itself. Now that it's by itself, I can take the natural log of both sides. So right up here I said, well, so what happened to this side? I took the natural log of it. Natural log and e cancel each other out. I just have 0.026x on the left. On the right-hand side, you have the natural log of that quotient. And then I can say, so my final answer is just that natural log divided by the coefficient of x, the negative 0.026. And you can do that here on your calculator. I said, or actually I haven't done it yet. I'll go ahead and do it here with you. We have the natural log of 2.57 divided by 41.1. So I'll create a fraction, alpha y equals enter. I have the natural log of a fraction in my numerator, and it's 2.57 over 41.1. I'll close that natural log off. I'm dividing that by a denominator of negative 0.026. So when I do this, let's see what happened. When I do this on the calculator, I accidentally put a minus. Please don't put a minus. You have to put a negative. Sheesh, John. Divide by negative 0.026, and I'll get 106.619. Now, round to the nearest number, that's going to be 107. So it says the world population will be 10 billion in. Well, I'm thinking the original, it was the x years after 1959. I found x to be 107, so I'd say plus 107. So it's going to be 10 billion in the year 2066 rounded to the nearest number. And we put our 2066 right here. I'll say, let's go 2066, and we'll check that answer. And it's saying nice work. That's what you got to do to get that problem. So that was an excellent question. Be glad to help you out with any others. Just let me know.